allows you to use broken propellers as a folding propeller design. Not on fire, so that's a pretty good sign. This could end in disaster. Let me get this post-it note right here. Hello everybody, welcome back to RC with Adam. My name is Adam. I am super excited right now because I just had another amazing idea, which might work or might not. This right here, this is what has gotten me so excited. And you say, what is that? Is that a fidget spinner? Is that a flux capacitor? No, I already invented a flux capacitor, so that's kind of an old thing. What this is going to be a device that allows you to use broken propellers on your motors as a folding propeller design. And if it works, it's going to be amazing. So I'm gonna bring you along for the journey. And if you're one of those people that doesn't like the whole how I built this kind of journey thing, then check the description below if you wanna just skip right to the, the good part where everything is, finished. Although some people say it's the journey, not the destination. So think about that. Also, I invite you to watch this at
double the speed. You can adjust the speed down there in the corner. Sometimes it's just funny to watch me talk twice as fast.
Let's get started. I'm Mr. Caliper. I can't move it fast enough. I'm gonna draw a very, very basic shape. So we have a circle here, that's going to be for the center hub. And then let's just say we're just getting dimensions here, rough dimensions. Okay, here we have the very first test prints, very rough test prints. So I have a few different designs here to see what works and what doesn't. Mostly I just want to see how the sizes are gonna work out. So one big factor is going to be this. Do they fit on the motor shaft? I would rather have it a little tight than a little loose. This might be too tight though. The big thing about how these propellers fit in place. So the idea here is that for this one, we have the remaining propeller hub from the broken propeller. We can actually lock it in here, and there's gonna be another half. I only printed one half of each hub in total. The fit right here is actually pretty decent. Well, of course, right now I'm working with Tinkercad. I know Tinkercad is not super precise and stuff, so I'm gonna be doing the final design on something else like FreeCAD or Fusion 360 or something. But this works good enough to get some prototypes going. I have to think about the propeller hub and how the dimensions might be different, like allow for some roughness of the propeller hub. These side cutters work really well, but it's still not going to be perfect. So I want to build in some tolerance in yet. But the other thing about these designs is that the idea here, oh dang, that's actually a pretty good fit. Oh, this could be this. Wow. Ooh, hey. I'm just so excited. I'm having trouble staying on one train of thought. Right, so the two different ideas that I had for the design of this is one, that it would be made to capture the blades and actually hold the blades in place. And so you would basically loosen the nut, and then you could rotate the blades, and then once you get the blades how you want them, you lock them in place. Now the tricky thing about that is if you totally lock them in place, well, then you might have one blade out farther than the other. So I think the best thing really, it would just be like having enough friction so that they're not freely moving, but they'll still be flung into the proper position, as opposed to just be totally free spinning like this design, where we actually are capturing the propeller hub, but it's allowed to rotate. And I actually really like this one. This was the first one that I designed. And then this one right here, which again, it's obvious to me now that it's too flimsy. I need to beef this one up a little bit in just the right spots. All right, back to the drawing board and the printing board and all those boards. Take a look at these things. I'm realizing that printing with a 0.6 nozzle is really just not good for small items like these, because these are small. Fortunately though, I have the ender set up. I'm just getting that started, but I have a 0.4 nozzle on there, so I think I'll do the rest of these prints on the ender. So this one, you can see it was too thin and it actually warped. So this is not very good. This is not ideal. Will this fit? Ooh. Oh, still not quite. I think I increased it by like 1 or a 0.1 millimeters or something. That is kind of the key that's making this thing tricky. Gosh darn it. All right, well, anyway, we can see at least that, and again, you know, the thing about using Tinkercad, like this is, I know it's not ideal, like it's not a good idea basically. I'm not even sure if these are a perfectly symmetrical triangle. But anyway, we get the basic idea here. This is very rough. Honestly, it's kind of embarrassing because this is not quite what I imagined. But you know what? I am just so freaking thankful that I have the technology and the skills and the ability to create parts that are as detailed and as dimensionally accurate as this in a matter of minutes. And I know we can make it better, so that's fantastic. Oh, okay. Yep, that came off. Gosh, these are very they're not overbuilt. Oh. Okay, so this is a great fit. Great fit there. Plenty of clearance. Clearance. Okay. All right, we're getting close. We're getting close. Wow. Yeah, okay, so basically exactly the same. But let's see, is it gonna fit? Perfect. Oh my gosh. Let's just see how it looks. Oh, look at that. Good enough. There's on here. And get the overall distance closer. Let's put this on. Yep, there we go. Ooh, very nice fit, very nice fit. So now I'm actually starting to think, hey, this actually is maybe not good. Let's leave this loose so we can see it spin. So look at that. Now everything is locked on there, man. The thing is locked on. There's just not quite enough clearance. That's all there is to it. I'm actually thinking we could potentially increase the strength of the whole part by taking these sections. There's my there it is. At least add some sort of body to this section, some extra rigidity. But you know what? Here's the thing though. I really just need to test this out because I don't even know if these things are strong enough at all or what's going on. Okay, all right, that was super fun. We're gonna make those design changes and we're gonna keep on chugging and we're gonna keep it freaking simple because otherwise I'm just gonna go way too crazy on this, trying to make it all fancy. Also, although this seems really cool too. What if you did it like this? I'm definitely gonna try this out. would that even work? It's producing way less thrust, which is very, very interesting. You see what's happening here? It's like I can't stop playing with this problem, or with this, well, because of the potential, you know, it's an interesting problem. All right, back to it. So this way, everything will clamp down on there. And I have not tested the fit yet, so we're about to find out right now. Oh, and then you fold everything up. You fold it up. Oh, well, look at that. Look at that. We're testing this out right now. So the way that this is, because of how large I made the inner things, you actually can't fold it more than like this far. So I'm going to say 180 degrees.
This is going to be with this style, this battery. The motor just shook loose because there was too much vibration. Yeah, okay, well that tells us something though. We're using this design right here. We got up to about half throttle, and you can see these are very free moving. Got up to just over half throttle. Okay, well I found this one was a few feet away, and then I found this one like probably like 30 feet away. That one kind of broke off more cleanly. This one, same deal with the angle kind of thing. So it's just too thin. That's just what it comes down to. It's just too thin.
Here we go. Here's our beefed up versions right here. Just to give you an example here, here's the old style. Oh wow, these are a lot bigger. Let's put our propellers in. They do fit. They fit well enough though, like that, because I didn't change the dimensions of any of the internal stuff. I just increased basically the outer edge. It's pretty thick. This whole thing is pretty thick. Let's see, notice here. Uh-oh, did I screw this up? It looks cool though, looks pretty neat. We shall see. I've got a good feeling about this though. One more thing, I also just bought these Lumineer propellers from Get FPV. These are folding propellers. What are these? These are, this has got to be at least 6-inch. So look at the difference there, the width, the difference. So yeah, you can see there's a big difference because the propellers get very small towards the hub. So you can see here the blades are definitely longer. Kind of similar though. These ones fold only this far. Pretty much like this one as well. There's that for a size comparison. Now back to making and testing and stuff.
We're gonna do some more testing with the thicker style.
I basically just have a motor clamped down.
4-cell, and we'll see if we can get to full throttle. That's kind of the goal. All right, we got up to full throttle. Okay, I guess I must have cooked the motor.
This is successful. It outdid our motor, which I guess doesn't say much because this is a really crappy motor. Here's our motor testing setup. right here. So just in case I didn't mention this before, this is actually from the OG Wizard X220. This is a 2300 kV 2205 motor, and it's certainly not the best motor, certainly not the most powerful motor, and it's certainly not made to swing this large of a propeller and this much weight, especially at 4-cell speeds. So that was a little silly on my part to do that. Because I smoked the motor. The windings got too hot, and so that lacquer or whatever is used to seal and insulate the windings got too hot, and so that's why it started to smoke. So that's no good. You can see the black, kind of the black areas on the windings right there. Okay, now we have a bunch of them. I think it's time for a live subject test, and by live subject I mean a quadcopter. So we're gonna get a quadcopter that we don't mind testing things on, and I gotta cut up some propellers here so we can actually have some props to put into these hubs. All right, here's the situation. This is the Wizard X220, but I have different motors on here, and what I realized is that these motors, the motor shaft for the propeller is not long enough to actually hold the new propeller hubs. So what I'm gonna have to do is I'm gonna have to take off these motors, which I think still work, which are from the 5-inch propeller on a 3-inch frame project. Oh, this is actually a perfect example right here of why you might have a propeller that 2 of the blades are clearly destroyed, but you still have this one blade that might actually work. And then I'm also gonna have to swap out the actual motor bell and the motor shaft and all that stuff from this other motor and put it onto this one, because these Lumineer motor shafts are also not quite long enough. Unfortunately, we won't actually be able to use the full blade length because these are just, they're just a little bit too long. For this, I'm just gonna cut them straight off. Look at that. Is that not fantastic? This is the first live test. Okay. Ooh. Okay. Again, we're running a 3-cell tattoo battery here. All right, so this is actually working. This is actually working pretty good. We're gonna give it a full flight test run here. Flight test run. Yeah, we're gonna do a real test flight, and we're gonna start out nice and easy, just see if it'll do a couple laps, and then progressively go more crazy from there. We're using an old Tattoo 3-cell 1300 milliamp hour battery, and we have the Hero 8 on there doing slow-mo. There we go. Okay, so far so good. I know the weight of the GoPro is really not good for it. It's definitely sliding all around because we don't have a whole lot of grip, and we have a lot of weight. So we're not going to do anything too crazy, but I just want to get some shots of this. Let's see if we can do a lap, okay? Let's see if we'll call this a success if we can do a little lap here. Oh my gosh, this is pretty hard to handle. Pretty hard to handle. Getting a little bit of break up, getting a little too low there. Let's just come on through here. Woo! Alright. So, there's a lot of reasons why this wouldn't be handling well. One is that it's 3-cell, the other is that it's a very old flight controller in ESCs. The other thing is that it's heavy and it's unbalanced. And also, what's the other thing? Oh yeah, we're not really using like real propellers. We're using experimental propellers, but honestly, Seems like it's doing okay. I guess the real test would be like, can we use this for just kind of cruising, getting some nice cruising flight footage, you know? So really, I'm able to cruise and stuff, and I'm not even near like half throttle. Maybe I'm near half throttle. It's hard to tell because I don't have an OSD thing to tell me whether I'm at what throttle position I'm at, but honestly, we're doing pretty good. That was a full power punch out. That was a full power punch out right there. So that's really, really good because we know, I mean, this tells us that this thing will handle 3-cell power. While we still have a little bit left, let's do a roll. Okay, all right. Should we try a power loop? I don't know. Nah, probably not. No, we shouldn't try a power loop. We could try like a little like flip over thing. Like that, little split S. Maybe. Huh? Maybe like a little split S and a dive. Sort of. That's not really a dive, but I mean, we're definitely going decently fast-ish. And honestly, at this point, I'm just flying this like a normal quadcopter that's been balanced very, very poorly. All right, let's bring it in for a landing. That is I would say that's a great success. Okay, so that it's not on fire, so that's a pretty good sign. Stepping it up to 4-cell this time. We'll see if we can do some kind of freestyle sort of moves. This could end in disaster. As long as it doesn't catch on fire, we're gonna be fine. All right, we are ready to rock and roll. Okay, so we have a lot more power, for sure. Definitely smoother, kind of. I mean, well, we have a lot more power, I don't know. Feels smoother, seems smoother. Let's just come in on here. These are kind of different rates from my normal rates. I'm kind of trying them out, so I'm not really used to them. I have to remember to kind of take it easy because, like, I don't want to completely destroy these and my camera. All right, let's say we're coming in here. We want to do like a wall ride. That kind of works. Okay, let's try it again. Oh, I was pretty sure that was going to break it. Okay. Oh my gosh, I'm really surprised, honestly. Do a little orbit down here, come in here. A little zippy. Oh no. Oh. Let's go see if it's on fire. Ooh. Well, it's not on fire. See, now I just think everything is going to catch on fire. What happened? Ooh, it broke. Well, we were doing really good, though. Good job, GoPro. This is your first real test of being broken in. This, like, totally works. Let's take this back to the studio and get a closer look. Let's take this apart and see what kind of damage we have. So take notice here that this is the back left or back right propeller here, and we had the GoPro mounted right out here, so pretty far back. So I'm thinking that what happened is because we were kind of pulling out of that sort of a power loop, I think that there's too much weight on the back, and so this back right motor had to spin up extra fast. I think that's one of the reasons why this broke here, and it was just too much force too quickly, and it just broke off. Let's pull the whole thing off of there. So our motor's okay. We got to clean it up, but it'll be fine. And there's the hub. That's where it broke. So this whole bottom section just broke right off. And then the top plate is fine, but then the actual stud holding the propeller broke off. You can see there's a little bit of warping, bent upwardness on the top plate, but not much. We started out with some gap, vertical space, but now it looks like we have a lot of bending on the top. And that makes sense because these propellers are going to be bending upward as they're spinning. Go ahead and take a look at the rear left propeller hub. Everything seems pretty well. Doesn't look like there's any excessive flexing. I'm not really crazy about how much play there is in here to begin with. I think we could make that a little bit shorter, make it a little bit of a tighter fit on the propeller hubs. Now that I'm looking at it more closely, I do see that there is some bending, some smushing going on of this post right there. Well, it actually worked. This idea actually worked, which is pretty cool because not all of my ideas work all the time. So what are some of the things that we learned? Because this is very important, because this will help us in future projects by taking a look at this and realizing what did we learn, what worked and what didn't work. Well, one thing that I learned is that Tinkercad is great for designing simple things, but for this type of project, it's not the best. And Fusion 360 or some other type of CAD software is fantastic, even though it does take a little bit to learn how to use. Probably most of the time that I spent actually designing this was because I was kind of learning as I went. But I'm glad I did, because this was a great project to actually work on and learn how to use that software, which I've been meaning to do. The other thing that we learned is that PLA is pretty darn strong, but it's not super strong. So probably not ideal for this application, but a few design changes could be the difference between your design completely working or completely not working. But I think it's really interesting that we did, even though we have this, kind of very prototype design propeller hub, we had to cut the propellers down so they're not super exact. Probably a lot of vibration, definitely extra weight for the motors. We were running on a 3-cell battery at some points. We still actually got some really great GoPro footage, and the propellers still totally functioned. Like, we were able to fly around. So that is surprising to me, that we were actually able to get that good of footage from the GoPro. So I would say that's something that I learned, is that the GoPro takes really great footage, even in 120 frames per second. So that was super cool. I'm gonna be doing more freestyle stuff with that GoPro for sure. One of the things that I learned is that it's best to just stick with one design that you want to try out and really focus on that. So like, I made these other cool designs, which I may visit in the future. In this case, it just made sense to focus on one design and test it out. And remember, don't worry if your first designs don't work. That's the whole point. You design something, you make a prototype version of it, you test it out, and then see basically how it fails, and then you can make it better from there. The other thing that we learned is that these propellers, when they're being spun very fast, there's a lot of force going on with these propellers, pulling them both outward and upward. You might be wondering if you can get the files for these so that you can 3D print your own propeller hubs, and I will not be releasing those yet. I want to do some more testing and maybe some design changes and test out some different filaments before I release those. And for legal and safety reasons, I have to say I can't recommend that you do this, and this should in no way guarantee your safety if you do it. So if you want to replicate this project, do so at your own risk, and please don't sue me. I have got a bunch of other projects that I need to start working on, but I don't think this will be the last of this project. I want to do a 2-bladed design as well as a multi-bladed design. And how many is multi? Well, you'll just have to wait and find out. I hope this has inspired you to give your designs a try. If there's something that you've been wanting to create, something you've been wanting to build, go out there and do it. Please do it safely, and you never know, it might work out really well. And if it doesn't work out really well, then you don't have to waste your time thinking about it. You can move on to the next design. Let me know what you thought of this. Let me know what you learned in the comments below. Thanks so much for watching, everybody. If you like this video, you will probably love this other video right over here, where I take 5-inch propellers and put them on a 3-inch quadcopter frame. Thanks for watching, and I'll see you again very soon.